Hi, my name is Jiale. In this video, I will demonstrate a SQL generation system developed by Cornell Database Group. SQLBarber leverages large language models to generate customized, constraint-aware, and realistic SQL. Database research and development require extensive tests and benchmark to ensure the updates are useful and there is no performance regression. In this process, we need a large volume of SQL queries. However, due to privacy issues, it is hard to obtain real-world queries. Our motivation is that we cannot get these queries directly, but their profile and runtime statistics are always available. So we develop SQLBarber that given profile and runtime statistics generates queries for testing and benchmarking purposes. Instead of randomly generating queries like existing methods do, we want the generated queries to have real-world properties. Firstly, we want the queries to have customized SQL templates. We use large language models to create templates such that users can provide specifications in natural language. Secondly, we want the generation process to be constraint-aware. That is, the cost distribution should match a user-provided distribution. The cost could be cardinality or execution time and more. Finally, we want the generated queries to be as realistic as possible. SQLBarber analyzes real-world statistics from Snowflake and Redshift to derive realistic constraints. Now let's experience SQLBarber step by step. On the left side, users can modify configurations. For SQLBarber, we can modify the task name in the format of DBMS name, database name, and any user-specified label. Then we can specify the number of queries to generate, the cost type, and its value range. We can use cardinality, execution plan cost, or execution time as optimization target. Next, we can adjust the number of profiling samples for template and the number of optimization iterations. For large language models, users can provide their API key and select a desired model. Next, users can provide their customized specifications for SQL templates. For example, the SQL should have at least 3 joins, or it should access 30% of tables. After configurations, we can run SQLBarber now. First, we can explore and select real-world distributions from Snowflake and Redshift. We click the Select item to use the corresponding distribution. Next, we move on to the SQL template generation step. Users can view the prompt used to invoke large language models with the placeholders for database schema and user specification. Now, users can click the generation item and view the generated SQL templates with some meta information to review. Note that each template has some predicate values to be replaced later. Once the templates are generated, it's time for initial profiling. In this phase, SQLBarber randomly samples predicate values for each template. This is to evaluate the ability of each template to produce queries with different costs. We can see that different templates can produce queries of different costs. Knowing the ability of each template, we can start our optimization process. The optimization is to identify a set of queries that match the target cost distribution. And each iteration is a Bayesian optimization process to explore different predicate values. And this will produce queries to fill the cost ranges that are still short of queries. As iterations continue, the current cost distribution becomes more and more similar to the target distribution, and we use a mathematical distance to measure the similarity. After optimization, we can view the distance of iterations and see the time cost for each step. Finally, we can export the generated SQL queries for benchmarking purposes. Thanks for listening, and for more details, please refer to our paper or feel free to reach out.